Greetings of the day. I am Dr. Jisha, covered in this section of working of bipolar junction transistor. The invention of the transistor done by John Bardeen, Walter Bardeen and William Shockley in 1947-48, which led the invention of the many other semiconductor device including the integrated circuit. And in fact, due to this integrated circuit, the modern day computer and other electronics gadget which we are using is possible. So, the bipolar junction transistor BJT is three terminal semiconductor device. In this figure show how to look bipolar junction device. In this figure clearly show the three terminal. C means collector, B shows the base and E means emitter terminal, the most important part of the BJT, which can act as a conductor or insulator based on the applied input signal, and due to this property a transistor can be used as a switch in digital electronics, or it can be used as an amplifier in an analog electronics. In this figure there is a figure A is present digital electronics and the figure B is present the analog electronics, and digital electronics is more accurate as compared to analog, as well as digital electronics uses binary data, but analog electronics uses decimal data. So, nowadays in the field effect transistor are widely used in the electronics industry, but still the bipolar junction transistor are by BJT extremely used, and anyone who is interested in the electronics should have some basic knowledge of bipolar junction transistor. So, in the bipolar junction transistor there are three doped region, the emitter and the base and the collector. The bipolar junction transistor is constructed with three doped semiconductor region in separate by two p-n junction. The figure show the NPN transistor. The leftmost N is emitter, the rightmost is collector, and the middle one is base. And symbolic presentation, the topmost is emitter and the bottommost is collector and the middle one is base. This figure shows the NPN symbol and NPN transistor symbol characteristic, and based on this doping these three region it is known as NPN and PNP. So, in the case of NPN transistor, both emitter and collector doped in the p type impurity, base doped into a p type impurity. On other end, in the PNP transistor the base is doped into n type impurity and the emitter and collector is doped with the p type impurity. In this figure, collector side p width is more as compare emitter side p as well, and is base that provided low resistivity show that current can easily flow from collector to emitter for NPN, and just opposite flow of current for PNP by controlling base. And this figure shows the symbolic presentation of NPN transistor. Here you can see that the arrow is outside, so this is the symbol of NPN. Here the term bipolar indicates that both electrons and holes contributes in the flow of current. Now, if you look inside the BJT, there are two p-n junction. one between the ammeter and base and second one between the base and collector, and it's appears as that two back to back diode are connected in the series, but actually it won't behave like that, because when we connect back to back diode, then we are assuming that there is a no interaction between the two diode. That means the two diode are operating independently, but in the case of BJT actually there is an interaction the two region. So if we connected the two back to back diode, then it won't behave like BJT. Now if we talk about like bipolar junction transistor, now we talk about the internal construction of BJT. Then the ammeter is heavily doped and the function of ammeter is a supply of electrons, and in fact that is why it is known as ammeter. Then if you talk about the base, then it is lightly doped and the doping concentration of the collector is between ammeter and the base. That means the collector is moderately doped. And if we talk about the width of this three region, then the base region is much narrower as compared to the region. So in terms of width, the collector region is wider than the other two, because of the job of collector region is collect the electron which is supplied by the ammeter, and in fact that is why it is known as a collector. Now depending on the biasing, the BJT can be operated in three region. Transistor consists of two PN junction, ammeter base junction EPJ, collector base junction CBJ. Operating mode depends on biasing. Active mode used for amplification, cutoff and saturation mode used for switching. In this figure, the depletion layer do not have the same width because different region have different doping level. This figure show the depletion layer of transistor. Depletion layer are in between of E to B as well as B to C. And there is a three region. First one is active region, second one is cutoff region, and third one is saturation region. In cutoff region, EBJ is reverse mode and CBJ is in reverse mode, but an active region EBJ is forward mode and CBJ is reverse mode. Saturation region EBJ is forward mode and CBJ is forward mode. This is the diagram of active mode for NPN transistor. In this figure, ammeter base junction is forward biased and the base collector junction is reverse biased. So, let us say the voltage at the ammeter is VE, the voltage at the bias is VB, and the voltage at the collector is VC. And to forward bias the base ammeter junction, the voltage of base should be greater than the ammeter, and similarly to reverse bias. The collector base junction, the voltage at the collector should be greater than the base. That means to operate the BJT in the active region, we can say that the collector voltage should be greater than base voltage and the base voltage should be greater than ammeter voltage. So, once this condition is satisfied, then the BJT will operate in active region. Two external voltage sources are required for biasing to achieve it. let the emitter voltage is VE, base voltage is VB and the collector voltage is VC. For active mode, the VB is greater than VE and VC is greater than VE. That means VC is greater than VB and greater than VE. Also, the total current flowing into the transistor must be equal to the total current flowing out of it, that is from the figure, and IE equal to IC plus IB. One thin layer of P type sandwiched between two layers of N type, and N type of emitter more heavily doped than collector, with VC is greater than VB and VB is greater than VE. Base emitter junction forward biased, base collector reverse biased. Electrons diffuse from emitter to base from N to P. For active mode, there is a depletion layer on the base collector junction, is no flow of electron allowed, but the base is thin and emitter region is N plus heavily doped. That means electrons have enough momentum to cross the base into the collector. The small base current IB controls a large current IC. It is observed that most diffusion electrons will reach boundary of collector base depletion region. Because collector is more positive than base, these electrons are swapped into collector. In this figure and graph, when IC is constant for different value of IB, that means it act for active region. Also we can see from the IC versus VC graph, then 0 collector current is donated cutoff region and 0 collector voltage for different collector current is saturation region. That means in saturation emitter and collector are shorted manner. DC voltage for the bias transistor, collector voltage VC equal to VCC minus IC RC, base voltage VB is equal to VB plus VBE. For silicon transistor, VBE is equals to 0.7 volt. For germanium transistor, VBE equal to 0.3 volt. Current gain for BJT is denoted alpha and defined as function of electrons and diffuse across the narrow base region. The current gain is also expressed in terms of the beta of transistor, often called HFE by manufacturers. Beta is temperature and voltage dependent. It can vary a lot among transistor. Common value for signal BJT is between 20 to 200. Magnitude of IC is dependent of VCB. Cutoff region, this is the region in which transistor tend to behave as an open switch. The transistor has the effect of collector and base being open. The collector, emitter and base current are all 0 in the mode of operation, where IC is equals to IE equal to IB equal to 0. IC is collector current, IE emitter current and IB is base current. Active region, cutoff region, both base emitter junction and the base collector junction are reverse biased. So, to operate the BJT in the region, the meter voltage should be greater than base voltage, and the same time the collector voltage should also be greater than base voltage. The cutoff region is when the transistor is inactive due to minimal current being passed through the transistor, which makes the transistor appear as an open circuit. Both VBE and VBC are reverse biased, so all depletion region edges exhibit small minority carrier densities. The region has biasing condition opposite of saturation. This figure shows the cutoff region of NPN transistor. In cutoff region, VE is greater than VB and VC is greater than VB. In collector region, ammeter and collector is an open circuit internally. In this figure, IB equals to 0, IC is equals to 0 and IE is equals to 0. Saturation region. In the case of saturation region of operation, both base ammeter and the base collector junction BJT are forward biased. That means in the region of operation, the base voltage VB is greater than ammeter voltage, and at the same time the base voltage also greater than collector voltage. This figure shows the NPN saturation region. This is the region in which transistor tend to behave as a closed switch. The transistor has the effect of collector and ammeter being shorted. The collector and ammeter current are maximum in the mode of operation. In the saturation region allows the transistor to conduct current from the ammeter to collector. The base current is so strong it exceeds the magnitude at which it can increase the collector current flow. As a result, the circuit between the collector and ammeter terminals appears to have short circuited due to the over saturation of current. In this figure, in the saturated mode, the collector and ammeter is shorted internal because there is a no depletion region. IC equal to IE. In this figure shows the collector and ammeter are shorted. In this condition, for saturation region, VB is greater than VE, VB is greater than VC, or IC equal to IE. So, this is the three region of operation. In case of the BJT, apart from that, there is a one more region of operation which is known as reverse active region of the operation. So, in this region of operation, instant base ammeter junction here. The base collector region is forward biased and the base ammeter junction is reverse biased. But in the region of operation, the gain provided by the BJT is very less, and due to that the region of operation is usually avoided. Similarly, if we talk about the PNP transistor, then in case of the active region. PNP transistor. The PNP transistor has very similar characteristics to the NPN bipolar cosine, except that the polarities or biasing of the current and the voltage direction are reversed for any one of the possible three configuration. In this figure, PNP transistor symbol, their leftmost side is a ammeter and the rightmost side is a collector, and the thin layer base is a N. The symbolic presentation also shown in this figure. The output characteristic curve for a PNP transistor look very similar to those for an equivalent NPN transistor, except that they are rotated by 180 degree to take account of the reverse polarity voltage and currents. This figure shows the PNP with their symbol and junction pattern. Positive terminal of a voltage source VEB is connected with emitter P type and the negative terminal is connected with the base terminal N type. Therefore, the emitter base junction is connected in forward bias and the positive terminal of voltage source VCB is connected with the base terminal N type and the negative terminal is connected with the collector terminal P type. Hence, the collector base junction is connected in reverse bias. Due to this type of bias, the depletion region a emitter base junction is narrow because it is connected in forward bias, while the collector base junction is in the reverse bias, and hence the depletion region at the collector base junction is white. The emitter base junction is the forward bias, therefore, is a very large number of holes from emitter cross the depletion region and enter the base. Similarly, very few electrons enter the emitter from the base and recombine with the holes. The small amount of base current controls the flow of a large amount of current through emitter to collector, provided that the base voltage is more negative than the emitter voltage. If the base voltage is not more negative than the emitter voltage, the current cannot flow through the device. So, it is necessary to give a voltage source in reverse bias more than 0.7 volt. Active region of operation. This base emitter junction is forward biased and the collector base junction is reverse biased, but in the case now the emitter voltage is greater than the base voltage, and similarly the base voltage is greater than the collector voltage. So, we can say that in the case of PNP transistor to operator it in active region, the emitter voltage should be greater than base voltage. Active PNP, the base voltage should be greater than the collector voltage for active region. In active region, VE is greater than VB and VB is greater than VC, so that VE is greater than VB and greater than VC. Similarly, the PNP transistor can also use for different reason. So, whenever the BJT used for the amplification, then it is used in the active mode. A bipolar PNP transistor will only conduct if both the base and collector terminals are negative with respect to the emitter. PNP transistor conduct when VE is much greater than VC. Now we discuss the summary of BJT characteristics in active mode. Collector to base voltage and the base to ammeter voltage are positive, and the collector current expressed as Is active VBE divided by VT IC equal to beta IB, and similarly for the saturation region VBE is positive and VBE is 0.7 if IC is non-negligible. VC is negative. One important point is noted that for saturation region IC is beta. One of the important point is noted that for saturation region IC is less than beta IB. VBE is 0.7 if IB is non-negligible. VCE is less than VBE. By definition, for cut-off region VBE is negative and VCB is positive and the collector current is 0. Now we can say this summary denotes the cut-off region, active region and saturation region, and last is reverse active. In reverse active VCB is less than 0 and VBE is also less than 0. To conclude this session, in this section we detail discussed about bipolar junction transistor, working of bipolar junction transistor for NPN as well as PNP transistor, and for both transistor we discuss the three modes of operation: cut-off region, active region, saturation region and also reverse active region. The most important is that we discuss in this section is cut-off region, active region and saturation region in detail. Now in this section we completed the bipolar junction transistor operation. Thank you.